Welcome to Study Loop.
This is the answer to Chapter 12, problem number 69 from the Smith Organic Chemistry textbook. And in this problem, we're asked to synthesize 4 molecules from 4 given starting materials. And we're told we can use any other required reagents. So to start with, in A, we need to get from this starting material here, this alkene, to a carboxylic acid. But all that we really need to do is add that carboxylic acid. We're not changing anything about the other carbons in the molecule or anything. And so a good way to start is going to be to install an alcohol. So a terminal, a primary alcohol here. And we can do that Okay, there we go. Sorry. We can do that by using, for example, BH3 followed by hydrogen peroxide and hydroxide ion. And so that's going to install the alcohol, the primary alcohol. So if we were to use, for example, sulfuric acid and water, that would actually install the secondary alcohol instead. But what we want here is this primary alcohol. Okay, and so there we go. And then from here, it's just a simple chromium oxidation. So we can use chromium trioxide, sulfuric acid. Help if I wrote the right reagents. So sulfuric acid and water. And so that's going to, remember, that's going to oxidize a primary alcohol like this all the way up to the carboxylic acid. So if we were to use like PCC, that would stop at the aldehyde, but we want the carboxylic acid here. And so chromium trioxide is a good reagent to use here. COOH. Okay, and so there we go. That's the product that we were asked to make for A. So then for B, we're going to do something somewhat similar. So we're starting from the alcohol here, the primary alcohol, but in this case, we actually want the ketone. So we want to go from this primary alcohol to a secondary alcohol on the next carbon over, and then we'll oxidize that. And rather than having a carboxylic acid, we'll have a ketone. And so we can so let me draw the starting material. So CH3, CH2, CH2, CH2OH. Okay, so the first thing we need to do is dehydrate this primary alcohol. And so concentrated sulfuric acid and water will dehydrate an alcohol. So we now are at this alkene. And so we can, again, use, so I guess the thing I forgot here is heat, right? So we need to heat an alcohol in concentrated acid and a little bit of water, and that will get us our dehydration. So if instead we use more dilute sulfuric acid here, and so more water and no heat, so now this is going to re-add that alcohol, but it's going to be the secondary alcohol this time. So there we go. And then from here, we can just do an oxidation. We could use chromium trioxide again, but I'm just going to use PCC. PCC is easy. CH3, CH2, C, ketone, CH3. Okay, and so there's our final product for B. So C on the next page here. So in C, we need to go from cyclohexene to this molecule with a ketone and a triple bond in it. And so a good way to start here. So here is our starting material. Okay, so the first thing I'm going to do is going to be to epoxidize this. So we have our epoxide here. And now, since we want that triple bond in the final product, one thing that we could use would be acetylide ion. So, and we can make that separately just by deprotonating acetylene, but we don't need to show that. So that is going to get us to here. So we have our opened epoxide, and then we have our triple bond installed. So that's good. We're close to where we want to be. And then actually, rather than treating this with water as a second step, I'm just going to make these a single step. So it'll be one acetylide ion and then a water workup. And that would get us, rather than the alkoxide there, we'll have the alcohol. Simple enough. And then we can treat that with some PCC again. And that's going to oxidize this alcohol up to the ketone for us. So ketone here now. And that is our final product for C. Okay. So then lastly, looking at D. What do we want to do in D? Okay, so in D, we have a cyclohexane with a triple bond sticking off of it. Okay, and so we want to get from there to a chiral epoxide. And so in order to do that, we're going to have to first install some carbons. Well, actually just one carbon. Okay, so we need to install one carbon, reduce to an alkene, and then epoxidize. And so that's exactly what we're going to do. Okay, so the first thing that we can do here would be to deprotonate this. So sodium hydride. Okay, so that's deprotonated. As I said, we want to add one carbon, so we can use methyl chloride here. Okay, and so now we're going to want to reduce this alkyne to an alkene, and we're going to want the trans alkene. And so in order to affect that, to get the trans alkene, we're going to want to do a dissolving metal reduction or a Birch reduction. So sodium metal and liquid ammonia. Is going to take us, Jesus, I seem to be struggling to finish drawing this cyclohexane. There we go. So that's going to take us to here. So the trans alkene here. Oops. Draw that a little better. All right. And then so lastly, in order to get to our final product, we're going to want to epoxidize. And so MCPBA will get us to our final product. And we'll also have the enantiomer here. Okay, and so that's what we were asked to make for D. And so again, the way to approach these synthesis problems is to compare your starting material and your product to see what changes you need to make, and then just select reagents that are going to make those changes that you need. And that's the answer to chapter 12, problem number 69.